Okay, I think we should kick it off. So, with that, just want to say welcome everyone. Thanks for joining. I'm Mia. I run product marketing at Flagsmith, and this is Kyle, one of our co-founders and founding engineers. And with that, Kyle, I will let you kick it off.
All right, brilliant. Yeah, hey everyone. My name is Kyle. I'm one of the founding engineers of Flagsmith, helped come up with the concept. Back in 2017, we were founding out of London back then, and today I'm going to be talking about how feature flags can be used as a safety net in the AI era of software development. Um, I've been sort of throwing myself into sort of using AI more and more over the past sort of 18 months. And it was actually a sort of a junior developer that encouraged me to do so. And I'm so glad that I did, just not having that inertia and sort of learning the sort of the positives and the pitfalls of AI. And I've sort of been thinking about how that can apply to feature flags. And I do see feature flags being a sort of vital tool in collaboration with AI development. So let's begin. Um, Before I get into things, what exactly is a feature flag? Feature flags have become more and more popular over recent years, recognized as a best practice approach towards feature development. But what exactly are they? I imagine a lot of you in the audience will be using feature flags, or at least thinking about using feature flags. But I thought I'd go over this anyway. Simply put, a feature flag is a way to deploy code to production, and that code is not executed until you turn on a feature flag in an external tool such as Flagsmith. So that means sort of pushing the code out to production if you use a feature flag does nothing on its own until you turn on that feature flag in a tool like Flagsmith. And this works both for new and existing features, whereby for new features, you simply create a feature flag, write your code as normal, but within a simple, pretty much if statement, checking for whether the feature flag is enabled. And for existing features that you want to make sort of big changes to, instead of deleting all of the old code and replacing it with new code, the idea is you keep the old code and then the sort of new behavior for that feature, you have that be under that feature flag check. So that means if the feature flag is off, the sort of legacy and the existing sort of behavior of that feature will apply, and only the new sort of behavior will apply once you enable that feature flag. And this might seem really sort of quite simple. So what's the sort of fuss about? Why is this being recognized as sort of best practice? Um, and there are a lot of traditional benefits of using feature flags that have nothing to do with AI, but they sort of pair with AI, and they are still relevant for this talk around AI. So firstly, above all else, feature flags reduce risk. So prior to feature flags, a lot of things had to be in place before you push out code to production. Everyone sort of had to be ready. Sort of QAs had to be happy. You had to have all of your end-to-end tests, unit tests. The business as a whole had to be ready. Product owners had to be ready, and even sort of other stakeholders such as marketing, who are maybe lining up sort of like press releases around features. They all had to be ready for you to simply push out code to production. So that means the act of pushing out code to production was just very risky, and there was a lot of reluctance to do so. Whereas with feature flags, this totally is not the case. Pushing code out to production on its own does nothing until you turn on that feature flag. And what that sort of results in is sort of once teams get used to using feature flags and get comfortable in doing so, there's a much more sort of fluid approach to pushing code out to production. And over my 12 years of being in web and mobile development, I'd say a large percentage of bugs that I've encountered are to do with sort of stale branches that are sort of laying around and not getting pushed to production for a couple of reasons. One, they get merge conflicts over time, and resolving those merge conflicts can get really sort of difficult. And then two, when it comes to actually releasing a bit of functionality that's been sitting in a branch for months, you kind of forget the context of what it exactly was about. And because you sort of forget that context, it's quite often that you make mistakes and make sort of false assumptions about the code that you wrote sort of months ago. So instead of all of that, you push code out to production a lot more sort of fluidly. Um, and then once the code's in production and you actually want to release to your end users, you don't have to do an all or nothing approach again. You can be as risk averse as you want. You can do targeted rollouts. So let's say rolling out initially to a beta test group, or maybe users using your application within a certain region, London, let's say. But then also, what you can do, since you can essentially define rules as to who sees that feature flag that you turn on in a tool such as Flagsmith, you can actually create a segment of users that reflects your own internal team, meaning that you can test in production. Now, testing in production used to be seen as this sort of bad approach to software development, a hacky approach, but with feature flags, it's actually sort of actively encouraged. We spend all of this time trying to replicate a production environment in terms of the data, in terms of the traffic, but we can never really perfectly replicate production. And production is the environment that our users see. It's the only real environment that matters. All we're trying to do is reflect that as closely as possible so that we can test in an environment close to what our customers see. But if you are using feature flags successfully, the code can live everywhere and you are encouraged to push more fluidly. So that means your code's in production. Why not test in the actual environment that your customers are seeing? You can enable a feature for your internal team before your end users even see that feature, which gives us sort of way more confidence that the feature is working versus testing in an environment that is not the same as what our customers are seeing. Um, and then you don't have to have your rollouts be to targeted sets of users. Instead, especially if you're working at large scale, you can sort of combine that idea with a progressive rollout. So let's say that you want to roll out a feature and you've got millions of sort of end users that use your application. You could start with a very low percentage of users, pair feature flagging up with APM monitoring tools, and see if there is an increased error rate as a result of that feature flag rollout, and slowly progress a rollout over time. And let's say things do go wrong. Things will always go wrong in software. There's no sort of avoiding that. But with feature flags, getting out of that situation is instant. You can just turn the feature flag off. Whereas before, especially with very complex sort of rollouts of code, you had to sort of scramble to like revert deployments, cherry pick commits if you were doing like a big release in one go, and then scramble to get a sort of fix out there. Whereas instead, you can turn the feature flag off and fix forward rather than fix backwards. So turn the feature flag off, don't rush, don't stress. Instead, work, figure out the problem, maybe keep the feature flag enabled for your internal team whilst you're diagnosing the problem, and fix forward. And then it's not just technical sort of benefits, it's the whole business really. There's a massive amount of reduced bottlenecks. As I was saying, a lot of things had to be in place before code could get rolled out. Everyone sort of had to be happy and ready before code could get rolled out. Whereas with feature flags, the idea is you sort of empower all of the different sort of areas of the team. Engineering is empowered because they are not having to wait on other stakeholders to push out code to production, because pushing out code to production underneath a feature flag does nothing if you've used the feature flag correctly. And then since engineers are pushing out code to production more fluidly, that means that other stakeholders are empowered because QA does not have to wait for engineering to push out code to a certain environment because the likelihood is it's already there. And they can enable features for just themselves without having to get engineering involved, and they can do their job at the sort of pace that they're wanting to do rather than having too many sort of dependencies. And from a sort of product owner's point of view and a sort of a business as a whole, again, you're empowered by the fact that you don't have to wait for engineering to push the button to sort of release code to production for your application to show that feature. Instead, the code's already there, and actually, the product owner and sort of delivery managers can sort of be empowered to enabling the feature when the business as a whole is ready. So a lot of time was spent on sort of this orchestration of things like big meetings, sort of saying, is everyone ready to sort of push the button and push code out to production? Instead, everyone's sort of more focused on their own tasks because there are fewer dependencies. Um, this leads on to discussing open feature. So, feature was an initiative we've been involved in since the get-go, and we really believe in the idea. If people have used open telemetry before, it's pretty much the same thing, but for feature flagging. Essentially, it's a vendor agnostic approach towards feature flagging. Instead of using a particular vendor's SDKs, such as Flagsmith, instead you use open features SDKs and it is agnostic to any provider, and you just specify what provider that you're using, and then it's the provider's job to conform to their standards. And that means if you're looking to sort of switch providers in feature flagging, instead of refactoring your whole code base because it's written in a certain provider's SDK, you only need to switch out the provider in one line of code with open feature. It's a great standard and it's purely open source, and we really recommend people check that out if they're getting started with feature flagging. So this leads on to talking about AI, the good, bad, and the ugly. As I say, I've been using AI extensively and forcing myself to do so over the past 18 months, and these are the conclusions that I've come to. Firstly, it types very fast, and seriously, the cognitive offload, the fast context switching, the big refactors that you can do, and sort of the ability to experiment more easily than before. So, not have to invest a load of time to sort of try out an idea has truly transformed the way that software is built. However, it's not all good. Definitely for the time being, it's not all good. It increases the need for safety checks and safety nets and sort of safeguarding the code that gets released to production. Because in my experience, AI is always confident and sometimes competent. And it's quite easy to sort of gloss over what AI is doing as you use it more and more. But in times where I've seen it complete a task that I know exactly how it should be done, I've seen it be very sort of confident that it's come to the right conclusion, only that I know there are big, glaring issues. And the more and more we rely on AI, and it is inevitable that we do so, like it is transforming the way software is built. And if you're not using AI extensively right now for your software development, I guarantee that pretty much every company in the world will end up sort of having quite a lot more sort of reliance on AI. Um, but this means we lose control sort of over our own code base, and more, a lot of our code is actually not written by us or any one of our team. Instead, it's written by AI. And this kind of means that if your app is broken, more and more we don't immediately know why, because the reason for it being broken might not be down to any code that we've written or our team has written, but it's actually AI that's written that code. So, sort of getting the context and sort of diagnosing the problem is quite a bit slower as a sort of result. And in the sort of more extreme cases, as one Google anti-gravity user found out, it might delete your D drive. Even this was an actual case that happened during the sort of initial release of Google's anti-gravity. It actually deleted their whole D drive, which is not very good. So, in all, sort of AI promises speed and efficiency, but it gives you speed. Um, and I want to sort of pair up this problem with feature flags because this is where I see feature flags being really key, along with other tooling, sort of a more robust set of sort of end-to-end test suites and sort of more just human checking of what sort of output is actually being written. But let's take the extreme case where we've developed a new feature purely with AI, but we're actually using feature flags as well. So AI produces this new feature that someone within the organization prompts out, but we do so with a feature flag. If we do so with a feature flag, that means we can push the code out to production, and that code is not going to get executed until we turn on the feature flag. So let's say we do that. To the end user, nothing has changed. We've pushed out a whole feature to production, and until we turn that feature flag on, the end user is happy and none the wiser because the feature flag is off. But then when it comes to turning on our feature flag for our internal team, we can see that the code is completely broken. Now, this is not really a purely realistic scenario, it's taken to the extreme, but with more and more code being written by AI is reality. And that safety net of having that feature flag and turning the feature flag on in production, or maybe pre-production, and sort of testing out before any sort of end user or even internal user that we don't want to interrupt their normal sort of usage of the application. They'd be none the wiser. So I see feature flags as sort of a superpower for AI, and where I see this being used in larger organizations, and I think larger organizations are claiming they're sort of using more and more AI, but with the amount of risk that's involved, I see the need for feature flags and sort of more safety checks. It's getting them to the position that they can validate ideas and sort of have big features get introduced into their own platforms at the speed of a startup and sort of validate using feature flags, enabling it for your own internal team, doing a slow progressive rollout with new ideas that would normally take up huge amounts of sort of engineering resource and resource from the whole team. And we took this idea, we've used feature flags, we've used Flagsmith since 2017. Pretty much all of our features have been rolled out using feature flags. So the idea of pushing out code to production quickly is pretty much ingrained into our culture. But we took this idea, a lot of us being new to sort of AI and software development, we all met up in Lisbon as part of an annual sort of meetup, and we did a hackathon where we ended up releasing 10,000 lines of code, largely AI sort of generated within our hackathon teams, and we're pushing for free large features to be used in production as a result of that. And on that day, we pushed all of that code out to production, and we were confident in doing so. We're not a startup. We serve some of the biggest companies in the world, so we couldn't just push code out to production because we're a new sort of startup and there's no risk. There was huge risk for us, but we were very confident in doing this because we had feature flags as that safety net, along with end-to-end testing and lots of unit testing. But still, the feature flag was absolutely key to be comfortable with rolling out such large amounts of code using AI. So this leads into introducing Flagsmith's MCP server. So the idea of this is to combine writing code with AI with automatically adding that safety net of a feature flag. So first step is you install the MCP, which essentially links your Claude or whatever you're using with the relevant feature flag projects. And you can even sort of tell the context within your applications to say, whenever you're starting a creating a new feature, make sure that you create a feature flag before you write any lines of code. And you can sort of configure that sort of context with any sort of best practice, such as a rollout strategy. Having the ability to, via a prompt, roll out a feature to internal users, or whenever you're creating a new feature flag, enable it for the local development environment, keeping it off for production. So all of this can be done without having to jump between writing code and go to Flagsmith. It all happens in one place. And what I'm going to do now is show you an example of us doing that. So here, essentially, we have a side project that I've been working on. It produces a lot of recipes and stuff to do with coffee because I love coffee. And we are using Flagsmith with this project so that we can turn on features with feature flags. And I've got a Claude terminal open here, and I want to write a new feature. So I'm going to paste this in. So I want this project to have a maintenance page. So if anything goes down and I want to just put up a maintenance page, I can do so behind a feature flag. And I've already told the Claude context of this project that whenever it's writing any code to do with a new feature, create the feature flag first. So I'm going to submit that command, and what's going to happen, pretty much as any normal AI development, it's going to look for the relevant sort of files within the project, and it's going to pick up that we are using Flagsmith under the hood, and it should create a feature flag. Though this is a demo using AI, which means that it's non-deterministic. But yeah, we can see that it's looking through the Flagsmith MCP right now, and we can see that it's getting the current feature flags. And I believe it's created a feature flag here, and it's enabled it for the local environment because that's what I've told it to do as a standard. And if I go to the production environment, we can see this new feature flag. It's still turned off, which is good because we only want to be able to turn that feature on when we're ready for our users to see it. So now that it's done that, it's starting to write our feature. So that's the key thing. It created the feature flag first before writing any code. And regardless of AI, that's something that I recommend that everyone who's using feature flags should do. And actually, we can see here that we've got the maintenance page sort of here, quite simple, but we've got it here. And I believe that, yeah, it's written the code to protect that new feature behind a feature flag. And that means if we turn this feature flag off, we should see the maintenance page go away. So now we're in a position where we can push out that feature to production. And as we can see with the feature flag off, the users are none the wiser because it's behind that safety net of a feature flag. So end to end, this is how we utilize AI to write features, but we have that safety net of feature flagging built in to our development. Um, cool. So that brings me to the end of the presentation. Um, I'll open up to any questions that the audience have, and if you want to sort of get any more information, I've got a link to our GitHub. We're fully open source. You can self-host for absolutely free, and there's a lot of information on our website as well. Brilliant. Are there any questions in the chat?
Yeah, I've seen a few that have come in through the Q&A, so maybe I'll read them, and then yeah, please feel free to put your questions in the chat or the Q&A as we go. So I think the first one, Kyle, was around the MCP. So for teams that are just getting started with the Flagsmith MCP, what's the simplest use case to begin with before working up to more complex AI release workflows?
Okay, yeah, this is a very good question, and I think thinking about this in terms of that is very good because it's the same as like how do I get started with feature flag? And the answer is kind of the same as well. You start with the simplest sort of approach that you can. So in this demo, what I did was I simultaneously created a feature as well as the feature flag. What you can start with is just creating a feature flag using the MCP. You could just install the MCP, open up Claude or whatever you're using, and you can say create this feature flag, and you'll be able to see it actually do that. And then you can start as you get comfortable, because it depends on where you are with using AI in software development as well. Maybe you're not using it yet extensively, and you can just get started by just having it create that feature flag via AI. And then as you get more and more comfortable, you can sort of bootstrap the sort of start of your feature writing process with what I showed earlier, where it creates that sort of skeleton wrapper in your code as well as creating the feature flags at the same time. Yeah. Were there any more questions?
I think you answered the other one that had come in, which was sort of around getting started with AI assisted code and where to sort of begin with feature flags. So I feel like you answered both of those in one
Yeah, I,
question.
I think one more thing to add to that question though is I think feature flags is a sort of an approach to having a safety net. It's like a tool in the tool belt of being able to push code out to production more quickly. Now, AI allows you to generate code more quickly. And I think a prerequisite to using AI extensively is a few things. I think you should have a very solid set of regression testing in place before you're using AI extensively. And I think you should have feature flags before you use AI extensively because these are the safety nets that are going to prevent you from losing control and having an absolute chaos of a sort of code base because you've used AI sort of too early and you've sort of jumped the gun. And with that as well, I think having really good context is so important. So telling your sort of telling AI about your sort of code base and your code standards before you're actually using AI to write the features is also extremely important.
Yes, well said. Okay, I don't see any more questions coming in, but I will make sure to share the recording and the deck with everyone that is attended today. So you will be receiving this, and please reach out with any questions that you may have after the fact. And as Kyle has shared here, very easy to get started with us, and also to chat with us if you feel like, yeah, asking your questions in person. So you can find all the info on the website. But for now, thank you everyone for your time today, and thank you, Kyle. This was great.
Brilliant. Yeah, thanks for having me.
Excellent. Okay, thanks. Bye.